Hello, hello guys. Today my new video is ISO-OSI reference model, that is chapter 5 of networking. So first, today I will describe ISO-OSI reference model. First, describe OSI. OSI stands for Open System. OSI stands for Open System Interconnection, where open stands to say non-proprietary. It is a 7-layer architecture with each layer having specific functionality to perform, and all these 7 layers work collaboratively to transmit data from one person to another across the globe. Across the globe, the OSI reference model was developed by ISO International Organization for Standardization in the year 1984. The OSI model provides a theoretical foundation for understanding network communication. How it usually not directly implemented it in its entirety in real world networking hardware or software. Instead, specific protocols and technologies are often designed based on the principles outlined in the OSI model to facilitate efficient data transmission and networking operations. Here are the diagram of OSI reference model. First, application layer, second, presentation layer, third, session layer, fourth, transport layer, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Total 7 layer. OSI model from sender's point: application, presentation, session, transport, network, data link, and physical. OSI model from receiver point: physical, data link, network, transport, session, presentation, application. OSI layers can be divided in three parts: hardware layer, where devices work like physical, data link, and network. Physical layer, hub, repeater, and end devices, and data link have bridge, switch, NIC, and network, router, L3 switch, and firewall. Second layer is code layer, where communication process is defined, and transport layer is the code layer. And third layer is software layer, where application work like session layer, presentation layer, application layer is a software layer. And transport layer is a code layer, and network, physical, and data link layer is a hardware layer. Tricks to remember OSI layers. Physical to application: please do not throw the small puppy away. And application to physical: from application to physical is sender point of view, and physical to application is receiver point of view. And application to physical, small trick is आज फिर से तूने दारू पिया. Here this process, you guys, it is a trick that you memorize this easily. And then PDU, protocol data unit. PDU are data units in edge layer. It is the combination of data and layer header. Each layer adds specific information to ensure the data reaches its destination correctly, and these steps are reversed upon arrival. Sender, build up packets, receiver. Sender are application, presentation, session, transport, network, data link, physical. And receiver also application layer. Here is a data diagram. In each layer, data is associated with a new tag or information. Layer based PDU, application layer data, presentation layer data, session layer data, transport layer segment, network layer packet, data link layer frame, physical layer bits. Example of OSI model implementation: Luffy sends an email to his friend Joro. Steve and Luffy interacts with email applications like Gmail, Outlook, etc. Write is mail. to send. This happens in layer 7 application layer. Step 2, mail application prepare for data transmission like encrypting data and formatting it for transmission. This happen in layer 6 presentation layer. Step 3, there is a connection established between the sender and receiver on the internet. This happens in the layer 5 session layer. Step 4, or email data is broken into smaller segment. It adds sequence number and error checking information to maintain the reliability of the information. This happen in layer 4 transport layer. Step 4, addressing of packets is done in order to find the best route for transfer. This happen in layer 3 network layer. Step 6, data packets are encapsulated into frames. The MAC address is added for local devices and then it checks for errors using error detection. This happens in layer 2 data link layer. Step 7, lastly, frames are transmitted in the form of electrical optical signals over a physical network medium like Ethernet cable or Wi-Fi. After the email reaches the receiver, i.e. Zoro, the process will reverse and decrypt the email content. At last, the email will be shown on Zoro's email client. Physical layer in OSI model. The physical layer is the bottommost layer in the OSI model that represents the physical and electrical representation of the system. It consists of various network components such as a power, flex, connection, receivers, cable types, etc. The physical layer sends data bits from one devices like computer to another device. The physical layer defines the type of encoding, that is how the zeros and ones are encoded in a signal. The physical layer is responsible for the communication of the unstructured raw data streams over a physical medium. Function performed by physical layer. The physical layer maintains the data rate, how many bits a sender can send per second. It performs the synchronization of bits. It helps in transmission medium decision and direction of data transfer. It helps in physical topologies, mesh, star, bus, ring decision topology through which we can connect the devices with each other. It helps in providing physical medium and interface decision. It provides two types of configuration: point-to-point configuration, multi-point configuration. It provides an interface between devices like PCs or computers and transmission medium. It has a protocol data unit in bits. Hub, Ethernet, etc. devices are used in this layer. Then this layer comes under the category of hardware layer, since the hardware layer is responsible for all the physical connection, establishment and processing too. It provides an important aspect called modulation, which is process of converting the data into radio waves, and by adding the information to an electrical or optical or nerve signal. Line configuration, point to point configuration. In point to point configuration, there is a line that is fully dedicated to carry the data between two devices. Multi-point configuration, in a multi-point configuration there is a line through which multiple devices are connected. Then modes of transmission media. Simplex mode. In this mode, out of two devices, only one devices can transmit the data and other devices can only receive the data. Example: input from keyboard would monitor TV broadcasting, radio broadcasting, etc. Then half duplex mode. In this mode, out of two devices, both devices can send and receive the data, but only one at a time, not simultaneously. Example: walkie-talkie, railway tracks, etc. Full duplex mode. In this mode, both devices can send and receive the data simultaneously. Example: telephone system, chatting application, etc. Physical layer protocols. Example are typically a combination of hardware and software programming makes up the physical layer. It consists of several protocols that control data transmission on a network. on a network. The following are some examples of layer 1 protocols are Ethernet with 1000 base T, and Ethernet with 1000 base SX, and Ethernet at 100 base T. Variants physical layer variation in 802.11 and Bluetooth. Then data link layer. The data link layer is the second layer from the bottom in the OSI model. It is responsible for the node-to-node delivery of data. Its major role is to ensure error-free transmission of information. This layer is also responsible for encoding, decoding, and organizing the outgoing and incoming data. This is considered the most complex layer of the OSI model, as it hides all the underlying complexity of the hardware from the other above layers. Devices work here are bridge, switch, NIC, sublayer of the data link layer. Sublayer of the data link layer. The data link layer is further divided into two sublayers, which are as follows: logical link control. This sublayer of the data link layer deals with multiplexing the flow of data among applications and other services, and LLC is the responsible for providing error message and acknowledgement as well. Multiplexing searching of network layer datagram protocol, error checking, flow control, acknowledgement, media access control. MAC sublayer manage the devices interaction, responsible for addressing frames and also controls physical media access. The data link layer receives the information in the form of packet form of network layer. It divides packets into the frame and sends those frames bit by bit to the underlying physical addressing MAC addresses segmentation of packets into frames, hide all complexity of sub upper layer function of the data link layer. There are various benefits of data link layer. Let's look into it. Then framing. The packet received from the network layer is known as a frame in the data link layer. At the sender's side, it receives packet from the network layer and divides them into small frames, then sends each frame bit by bit to the physical layer. It also attaches some special bits for error control and addressing at the header and end of the frame. At the receiver end, DLL takes bits from the physical layer, organize them into the frame, and sends them to the network layer. Addressing. The data link layer encapsulates the source and destination MAC addresses, physical address in the header of each frame to ensure node-to-node delivery. MAC address is the unique hardware address that is assigned to the devices while manufacturing. Error control. Data can get corrupted due to various reasons like noise, attenuation, etc. So it is the responsibility of the data link layer to detect the error in the transmitted data and correct it using error detection and correction techniques respectively. DLL adds error detection bits into the frame's header so that the receiver can check if the receiver data is correct or not. It adds reliability to the physical layer by adding mechanisms to detect and retransmit damaged or lost frames. Then, uh, then, uh, then next up is flow control. Here you can see flow control definition. If the receiving speed is lower than the sender's sending speed, then this can lead to an overflow in the receiver buffer. For and some frames may get lost. Okay, I repeat this. If the receiver's receiving speed is lower, if the receiver receiving speed is lower than the sender sending speed, it then um, sending speed, then this can lead to an overflow in the receiver buffer and some frames may get lost. So it is the responsibility of DLL to synchronize the senders and receiver speeds and establish flow control between them. Access control. When multiple devices share the same communication channel, there is a high probability of collision. So it is the responsibility of DLL to check the which devices has control over the channel, and CSMA-CD and CSMA-CA can be used to avoid collision and loss of frames in the channel. Protocol in data link layer. There are pages protocol in the data link layer, which are as follows: synchronous data link protocol, high level data link protocol, serial line interface protocol, all for encoding, and then point to point protocol, then link control protocol, then network control protocol, then network layer 3. The network layer works for the transmission from of data from one host to another located in different network. It also takes care of packet routing. Routing is a selection of the shortest path to transmit the packet from the number of routes available. The sender and receiver's IP address are placed in the header in the network layer. Devices work here are router, L3 and firewall. Function of the network layer. Routing. The network layer protocols determine which route is suitable from source to destination. This function of the network layer is known as routing. Okay, I repeat this. The network layer protocols determine which route is suitable from source to destination. With this function of the network layer is known as routing. Logical addressing. To identify edge devices inter-network uniquely, the network layer defines an addressing scheme. The sender and receiver IP addresses are placed in the header by the network layer. Such an address distinguishes edge devices uniquely and universally. Then transport layer. Layer 4. The transport layer provides services to the application layer and takes services from the network layer. The data in the transport layer is referred to as segments. It is responsible for the end-to-end delivery of the complete message. The transport layer uh, also provides the acknowledgement of the successful data transmission and retransmit the data if an error is found. Then at the sender side, the transport layer